Hey guys, Mr. Kruger here talking about the Chapter 7 test review. This is our blue packet that we got 2 classes ago. This is a great review and it looks very similar to the test. So what I'm going to do is I'm going to do a few problems from each section just so you guys can get the hang of each one. So we'll start with the first one. It says, I can complete the square to a polynomial to write in vertex form and list the vertex. Okay, so the first thing I have to do is I'm going to rewrite it with all the blanks. Okay, so I have x squared minus 4x plus blank minus 5 plus the other blank. Remember, I need to figure out what goes inside this blank. So the way to figure it out is you always take the formula b over 2 squared. Well, in this problem, the b is negative 4 over 2 squared. If you don't know where the b is, it's right here. Negative 4 is always in front of the x, that's the b. And then I simplify what's in the parentheses, gives me negative 2. Squared gives me a positive 4. And that's the number that goes inside of this blank. So now I take this, plug in the first blank. Remember, what I add I have to do the opposite to. So I don't want to change the value of this. So now I add a 4 here in the first blank and I add a negative 4 in the second blank. And now I'm going to factor this polynomial, and then I'm just going to combine like terms with these two numbers. So factor, I need to figure out what multiplies to positive 4 and adds to negative 4. And remember, it's got to be the same number twice. That's why it's a perfect square. Well, negative 2. So I'm going to write it as x minus 2 quantity squared. And negative 5, go further, negative 4 more, gives me negative 9. So here's the tricky part. I need to write my vertex. Well, it's going to be a coordinate. Good. Remember that the number outside is always the y value, and it's exactly the way you see it, so negative 9. But the number inside the parentheses is always opposite. So instead of a negative 2, it's going to be a positive 2. Okay. Let's take a look down here at the second problem. I can use different forms of the equation to determine what information I am given. Okay, so let's see what we got. Let's do the first one together. What form is this? Well, that's in standard form. If you notice, we have our a, our b, and our c. It's non-vertex form or factored. What free information do we get? We get the y-intercept right there. 0, 8, which is the y-intercept. It's always that c value. Then it says change the equation into an equivalent form, factored form or vertex form, that helps you see the x-intercepts. Well, x-intercepts. Vertex form gives me the vertex, so it's got to be factored form. Okay? And then it says also, what is the y-intercept? Well, we actually just did that, 0, 8. So let's figure out the x-intercepts here. So x squared minus 6x plus 8. So I need to factor, so I need to find the numbers that multiply to 8 and add to negative 6. So multiply to 8 and add to negative 6. Well, in order to do that, let's find negative 4 and negative 2. So I'm going to factor as x equals minus 4 and x minus 2. So the new function, it's equivalent because it's just in factored form now. F of x equals x minus 4, x minus 2. What are the x-intercepts? Well, if you wanted to solve them, let's go back over here. Set them equal to 0, so I get x minus 4 equals 0, x minus 2 equals 0. I really want you guys to do this because some of you guys are making the mistake of saying that the x-intercepts are negative 4, negative 2. So if I add 4 here, add 4 here, add 2 here, add 2 here, so I get x equals a positive 4 and x equals a positive 2. So my x-intercepts are 2, 0 and 4, 0, and my y-intercepts are 0, or my y-intercept is 0, 8. Then it says change the equation into an equivalent form that helps you see the vertex. Well, that's got to be vertex form. So here we go. X squared minus 6x plus 8. Start back in standard form. It's so much easier instead of multiplying back out and then going to complete the square. So it's the same process we did in the first question. Let's split it up and we get x squared minus 6x plus blank plus 8 plus blank. So I'm going to take negative 6 over 2, because that's b over 2 squared. So I get negative 3 squared, which gives me a positive 9. That's what goes in the first blank. But remember, we always have to do the opposite, which is a negative 9 in the second blank, because 9 minus 9 gives me 0. I don't want to change the value. Then I factor this expression up here, and I'm just combining like terms right here with the last two constants. So two numbers that multiply to 9 and add to negative 6 have to be the same number twice. Got to be negative 3. So I get x minus 3 squared, and then positive 8 minus 9 is a negative 1. So the new function is f of x equals x minus 3 squared minus 1. And then the vertex, remember that inside the parentheses it is opposite, which means it's a positive 3 for the x value. And outside the parentheses is the same, so it's a -1 for the y value. Okay, the last question on this page, given the function, it's in vertex form. The free information's got to be the vertex. And then it says, change the equivalent form to see the y-intercepts, and then the vertex. Well, we already got the vertex. It's 3 comma -4 just by looking right here. 3 opposite, because it says -3, and then -4 is the same as what you see it. And just to give you guys a hint on how to rewrite in standard form, if I have this function right here, I need to make sure that what it means to square something is to actually multiply by itself. So I'm going to write it out one time, and then you can just use your distributive property. And then combine like terms with the -4, and you'll get that new function. Okay, let's take a look at the next page. Okay, so we're looking at this next page. It says, graph each of the following quadratic functions, show all your work, and label the points on the graph. Well, question number 5 is a standard form equation we've done over and over and over again. Look at the last problem we just did to rewrite in vertex form to get the vertex, to rewrite by factoring to get the x-intercepts. And this one AOS, this axis of symmetry, we'll talk about it next class, but I really want to talk about number 6. Okay, so let's take a look at number 6 here. The direction, well, that's easy. The lead coefficient is positive, so it's got to be going up. The vertex, well, there's 2 ways to do it. You could use opposite of b over 2a, which we learned in the last class, or you could complete the square. Let's do opposite of b over 2a so we can practice this formula. So opposite of b, well, this is kind of a tricky one. X squared, there's no x there, so I'm going to rewrite it as plus 0x minus 9. So I can actually see my a, my b, and my c. So opposite of b, well, that's 0 over 2 times 1, which is a. So that gives me 0 divided by 2, which is actually just 0. So that's the x value of the vertex. Then I take that and I plug it into the function. So I plug it in for 0 squared minus 9. Well, that gives me -9. That means that the vertex, here's my x value, and I plugged it in to get my y value. So 0, -9. I'll talk about the axis of symmetry the last step here. The y-intercept is always this constant right here, which is -9, so we have 0, -9. And if you look, in this case, the y-intercept and the vertex are the same coordinate. That's totally fine. You're allowed to have that if that y-intercept is the minimum for this graph. It's going to be the vertex. Okay, x-intercepts. So we have x squared plus 0x minus 9. Now I need to find 2 numbers that multiply to -9 and add to 0. +3, -3. So I get x plus 3 and x minus 3. Set those both equal to 0. It's an equal sign. And now I solve and I get x equals -3, x equals +3. And those are my x-intercepts, 3, 0, and -3, 0. And now it says you got to graph all of it. So let's label all this stuff. 0, -9 is way down here. 3 x-intercept and -3 x-intercept. It's opening up. We'll draw a graph through this. Okay, so the last thing I want to talk about is this AOS, which stands for axis. Let me get some space up here. Of symmetry. That's what AOS stands for. And it's pretty straightforward. Okay, if you look at this U shape here, it is symmetric over the vertex in the sense that the left side of the graph looks exactly the same as the right side of the graph based off this vertex. And the axis of symmetry is a vertical line through the vertex. Because if I reflect over this vertical line right here, I'm going to get the exact same thing on both sides. So remember, a vertical line is an equation that has x equals, and it's always whatever that x value of the vertex is. In this case, 0. So it's a vertical line through 0, x equals 0. Okay? Let's try some of these. These are some good problems right here. So now it says, I can calculate the vertex of a function. Find the vertex. We'll keep in mind opposite of b over 2a if we can't complete the square. So let's try this one right here. Will this graph have a maximum or minimum? Well, it opens up because that lead coefficient is positive. So that means it got to have a minimum. And then what is it? So let's use opposite of b over 2a. Opposite of 14 over 2 times 1, because that's a. So I get -7. That's the x value, and then I'm going to plug it in. So -7 squared plus 14 times -7 plus 41. It's going to be a big one. Okay, -7 squared is 49. Negative 7 times 14. Well, negative 7 times 10 is negative 70, and then times 4 is 28, so 70 and 48 gives me a negative 98, and then plus 41. Well, 49 plus 41 will give me 80, 90, and then minus 8 will give me negative 8. So that's the y value. My x value is right here, and my y value is right here. So I get negative 7, negative 8. Okay, we've completed the square multiple times right here. Look at the front page and look at the second page. You'll see that we completed the square to get our vertex. Okay, and now the last question I want to talk about, because it's a little different because you're given a graph. Will this graph have a maximum or minimum? Well, this is the example that we talked about for the first question. It's opening in the up direction, so that means that the lowest point, its vertex, will have to be a minimum. Okay, and then it says, what is it? Well, let's zoom in here. I'm lucky I can do that. The x value is negative 3, and the y value is negative 2. So negative 3, negative 2. Perfect. Okay, a baseball is thrown into the air. The height of the ball in feet can be modeled by the equation. F of x represents the height, so the y value represents the height, and the x value represents the seconds. Well, remember, we did a type of problem just like this on the board last class. If you throw a ball, we're talking about seconds here for the x, and then the height is in terms of the y. So the important information we can find is that this ball, when the ball is being released, is the y-intercept, the vertex is the maximum, and then when that ball hits the ground, we get our x-intercept. So let's look at all this information here. Okay, let me throw that little picture out so I can zoom in a little bit. It says draw a sketch of the model first. Well, I'm lucky I just did that, so let's do it again. Throw the ball right here. There's the maximum, and then it hits the ground. Good. If you want to draw a little person, you can absolutely draw a little person. Right there. Nice. And it says, at what height is the baseball thrown? Well, that's going to be the y-intercept. That's when time is 0. Seconds are 0. So if you look, we have standard form, we have factored form, and then we have vertex form. All the information is given to us. We don't have to go between all the forms using completing the square or factoring and so forth. So y-intercept, that's what we're looking for here, because that's when the ball is thrown. Well, if you look right here, standard form, it's always the c value. So 0, 80, at 0 seconds, here's my height in feet. Okay, baseball is thrown in the air. That's pretty crazy. The height of the ball is 80 feet when he's thrown. That's kind of high. I don't know how that works out. Okay, let's try this next one. What is the maximum height? Well, that's got to be the vertex. Well, remember, here's my vertex form. Okay, remember it's always opposite on the inside, so it's going to be a positive 2 for the x value and a positive 144 for the y value. If you look right here, this is seconds, and right here is the height. So at 2 seconds, the ball is 144 feet in the air. And the last one, how much time does the ball hit the ground? Well, we got to use factored form here. So negative 16, x minus 5, and x plus 1. I know there's a negative 16 here, so if you want to set that equal to 0, you can set each part equal to 0. And let's watch what happens. So it's negative 16 equals 0. There's no variable there, so we can't solve for that. Doesn't affect the problem. Add 5, we get x equals 5, and we subtract 1, we get x equals negative 1. So this one's talking about how negative 1 seconds the ball hits the ground. Well, that doesn't make much sense, but this one really helps us out. At 5 seconds, the ball hits the ground as well. So here we go. Let's put all this information together. Let's plot some points. The first one, the ball leaves 80 feet on the y-axis. Remember, we got seconds here, and we got height here. Okay, ooh, that's a bad G. Okay, next we have the maximum height is 2 seconds in at 144, so right around there. That's the vertex, that's the maximum height that it reaches. And then the x-intercept all the way down here at 5, 0. If you want to plot negative 1, 0, you absolutely can, just so you can see the curve. Okay, but realize that if I wanted to look at an actual graph here, this is the only part of the graph that actually makes sense. Because obviously down here, the ball is not going to go below the ground, and right down anywhere left of the x-axis, that's negative seconds, and that doesn't make sense. So the only part that makes sense is that the ball leaves the hand right here at 0 seconds, travels up, reaches its maximum at 2 seconds, and then starts traveling down and finally hits the ground at 5 seconds. Maybe it rolls a little bit, but that's a whole new parabolic function. Good stuff, guys. So take a look at this question. Good luck on the review.